This is my Agon Light. You might have noticed I've made 1 or 2 videos about it. I'm trying to write a game the hard way for this thing. Well, in my game I'm mostly using the keyboard, but I want to use a joystick. Specifically this kind of joystick, the old style Atari one. I've had this joystick for years, it's literally like the joystick I had as a kid. But to make it work with this, it doesn't have any joystick ports on it. So we're going to have to build one. That's what I want to do today. Can I make a joystick port for this that works with this and then add it to my little game that I'm making? I have no idea because I've not done this yet, so let's go find out. We'll start by trying to look at this and work out how you'd even make a joystick work with it. Before I start trying to plug things into this, let's look at what I'm trying to plug into it. This is my joystick. It's a PowerPlay Cruiser from the 1990s in really nice 1990s colour style. Look at that. Pastel colours were the thing. Pastel colours are cool. Bring back colourful stuff. There's nothing to this. We're going to open it up and have a look inside. So it's just got 3 screws on the bottom. Okay, inside it is a bunch of micro switches. That's all there is. So we just have 4 micro switches that when you move the stick, press the micro switches, all the grounds are connected to each other. Then there's 1 signal wire off each one that makes its way down the cable and out of here. And if you look in the end of this, you can see that several of those holes are bigger than they should be because there's not even a connector inside it. And then because Sinclair existed and Amstrad and they had to make different wiring, there's a different plug. It's got this strange Y-shaped piece. We have to use this one, not this one. That's the entire inside of this thing. Whoops, its joystick fire button bar has fallen off. I have to work out how that goes back on. I think it goes on like that. And that's the thing. These 2 buttons do the same thing. They press that switch. So you don't even get 2 buttons. So this is a standard Atari joystick pinout. I'll put the pinout on the screen now. You can see it and how it relates to those connectors there. This is my Agon Light. It's a very small computer. There's the EZ80 CPU. There's its RAM. That's an ESP32, I think, that does the video. The video comes out of VGA. Then it's got a bunch of other sockets. Now we're trying to make a joystick work, and it looks like there's certain sockets on here that we could use. You know, there's a USB port here, which looks kind of interesting. The VGA port's just the VGA. And then there's a USB-C port here. And, you know, you might think that, well, I can just plug something into those. But they're not what they appear. This port here is just for the keyboard. It's even just marked up as keyboard on it. So there. And it says USB keyboard, but it's not USB. It's a keyboard like this one I've got here from my other machines. So it's one of these keyboards that comes with USB, but if you plug it into a PS2 converter, it does PS2. So that's what that port is for. It's just there so that you can plug a keyboard in without needing one of those converters. The other connector on here, this one, USB-C, is just for power, and it's also a serial debugging port. So we need to make our own little interface. Fortunately, we've got some GPIO pins, and even more fortunately, it's very easy to connect things to these, and then in C, we can write some code to read them. And they are GPIO, just like on an Arduino or something. You can just monitor the state of 2 bytes and get all these pins and what's been set on them. So that's what we're going to do. So this small board is the interface that we're going to build. It's got some basic code written on it to test the interface, so we'll be using that later. It's a very simple device. All it's got on it is 2 ports, 1 for each of the joystick connectors, and I've got some little angled joystick connector here. We need some 10k resistors, so I've got those somewhere. There we go. And then we need to connect it with some sort of connector. So this has one of these ribbon cable connectors. I had a route around in my box of stuff. I found this ribbon cable. It's got a weird PCB mount here, so I'm a bit undecided whether I should just mount this on here he says as he holds it off the camera and you can't see anything because these pins are tiny anyway. There we go. I could do that and permanently attach it because, you know, I got this created from an online PCB place that is not sponsoring this video, but you could do if you wanted. So, you know, I've got 5 of these boards. But yeah, I just thought I'd show you because this is where I got it from. It seems it's the only place you can get it from. If you search for 8 bits wide Agon Arcade joystick interface, it brings you here. So building this is quite easy. We just have to put the parts on and solder it together. Then we can run this code, see if it works. Right, my soldering iron is warming up. Let's build this thing. Right, there's all the resistors in. And yes, I know, they don't all have the correct orientation. But never mind. The next thing, let's put these 2 things in. So these just go in like this. It's literally that difficult. So there's 1, there's 2. And now I just need to do something with this. And I've decided that I'll put an edge connector on it, not an edge connector, pin headers. Put these in, and then I can plug things into it. My idea in the future is that these go in a case together, and I build a little case for them, so maybe they stack on top of each other, or something else, I don't know, underneath maybe. But make a little sort of console type thing, these 2 out of focus PCBs I'm waving around at you. Right, we need to put these in. Of course that would happen. Because nothing else wouldn't, would it? That's what the finished board is going to look like. Let's flip it over and do some soldering. Okay, the tedious soldering montage is over. I've built it. I just need to trim these off. There we go. It's built. And I think I accidentally switched my camera off partway through making that, so I think I lost a bunch of footage of me very boringly soldering stuff. So never mind, that saved you watching all that stuff in time lapse when you don't really care. Look, it's got resistors. It's got DE9 connector. It's got pin header. It's got some basic code. I think we'll go and try this basic code now, see if this works. Because if it does, it'd be a nice test of whether I've built something that's functional, or I've just wasted everyone's time building a bunch of rubbish. So this video, as ever, is brought to you by these cool people scrolling up the side of the screen at the moment. You could be one of these people if you want to. I'm not going to sell Patreon to you. You know the deal. It's the internet, it's YouTube. We know how all this stuff works by now. The link's around if you want to join in. If not, that's totally fine. Just enjoy the video. Watch me trying to make this thing work. I'm hoping by now that I've probably finished building the tiny little joystick adapter. So let's see what I've made. So, as you can see, I've got everything set up. I've got my nice little, it's an IBM PS2 keyboard, so you can't see it. There it is, look. It's got a PS2 plug going into a converter, into USB. This then just converts it back into one of these. Utter madness. They could have just put a PS2 connector on. I guess these were cheaper. So there we go. Right, this is the board I've just built. It's connected to the GPIO pins. There's fireworks going off outside because, you know, it's November. The Agon is booted. On top of the joystick connector thing is a little basic program that I'm going to type in. Right, so I need to type in the code. So first thing is we need to load BBC Basic. Load BBC Basic.bin. Run. Then you have to turn caps lock because basic only likes capital letters. So let's go. The writing on this is very hard to read. This is reminding me of being a kid typing out BASIC, where I don't really understand what I'm typing. I'm just hoping that I can type it in correctly, and that whoever wrote it also tested it and that it works. Okay, we're doing left. Left. X. Left. Right, I have no idea what this code is doing, So the first thing we'll do is we'll save this as joy test. Let's run it. No such variable at line 110. I'm right. Oh, okay. Yep, that is indeed wrong. Okay. Syntax error at line 140. Cool. This is BBC Basic. Y equals y plus 1. Oh, yeah, I see. Right. So it's printed some numbers. Amazing, it doesn't work. Let's try the other port. Fantastic. Oh, I think it is working. I think I just had a bad connection. Yeah, so we've got 1, 4, 16, 64. That starts at 3, then becomes 19. I'll plug it into the other one. 2, 8, 32, 128. Right, I'm reasonably convinced that this is working. The next thing to do is actually write some proper code, and not just a bit of basic I've typed off a PCB. This is what passes for my little test game so far. I just want to show you something before I actually show you how it works. Notice how there is a bit of flickering on the screen and it all looks a bit weird. I just need to update the emulator and I think that will fix it. So we need the Agon emulator. There's an update of this as well, which is newer. Fix graphical glitches in double buffered 64 color modes. So we download that, we get my terminal up. Right, let's run the code again. See if it has the same graphical glitches. No, look at that, that works nicely. There's two things that would make this emulator even better than it currently is. One would be some way of, in Linux, making it appear on a specific screen. The other thing would be somehow allowing the UART that's on the USB port to, even if it just prints text in the console. There is a verbose mode, but it doesn't print out the text from the UART. That'd be really cool, because I use that as a debugger. I'll show you that with the real hardware. I have my Agon Light connected to my PC through the USB port, just to provide it with power, but it also means that there is now a serial port that my PC can communicate with, and it sends data to the Agon Light. One of the things I can do is transfer data and binary files to the machine without using the SD card, using hex load send. And then on the real machine, I need to use another command to receive it. I can't quite remember what the command is, so I'm just going to root around the Agon's SD card and find it. Obviously, it's called hex load. So I start the receiving program on the Agon, and it just sits there waiting. I run the sending program on here, and it sends from one to the other. And it's done. Right, after some minor farting around, I've got a connection to the USB port that is now a serial port. So if I reboot my Agon, you'll see some debugging text on the screen. There, so that text is directly coming from the ESP32, which is what I'm communicating with. It's not the Z80 inside the Agon that I'm talking to. But now if I run my test code, you should see debugging output on the screen. There we go. What I've got is now a debug overlay that I can display. And when I press keys on the keyboard, it now shows me which byte from the key map and then which bit. So as you see, I now have a nice bit of debugging output where I can write text that doesn't have to go on the screen, so I can see a bit of a log of what my program's doing. And at the moment, all it does is you can press left and right and be in one of three places and this thing falls down the screen. The idea is going to be that you avoid the thing, and some of the falling things might be something you have to collect, and then it gets a bit harder after an amount of time. Trying to make a reaction game. So you can only be in one of three places, and whatever's falling will be in one of three places too. Currently it's still got the fake physics, so it bounces off, which is interesting, but then it disappears off the top of the screen. How this game works and where it's going will be a future video, so come back to watch that. We're still playing around with joysticks. And what I want to do is make the joystick work instead of the keys. I guess before we waffle on about joysticks, I need to explain how the keyboard works. I don't know why you're red. You've got the header file. Be quiet. So, what I've got is two arrays because we need MOS get keyboard map. It returns a pointer to the keyboard bitmap, which is always 24-bit. Right, here's your entire documentation for how to read from the keyboard. You have this function, get key map. You pass it an index, which is from 0 to 0f, and it will return an 8-bit integer, unsigned, which relates to a bitmap of which keys are currently being pressed that have been assigned to that index. So you press a key, you figure out which one of these it's come under and which bit is lit up. That's it. That's how you do it. Really simple, really straightforward. So I have an array of 16 of them for the previous key states, 16 for the current key states. I have a keyboard update function that copies them so I know what it was previous frame, and then I get the new ones and stuff it into that array. And that's it. I also have a few helper functions though. These are the bit indices, which sent me slightly mad trying to figure them out, and all of these are wrong. But this bit's quite useful. I can work out if a bit has been set, and then I've got is key held, which just checks that in the current key state that we've just read, is that bit set? Was key held is in the previous frame's key state, was it set? Pressed means that it's currently being held in this frame, and last frame it wasn't held, and released is like the opposite way around. You need functions like this or some sort of logic to do this. If you don't do it, when you press a key on the keyboard, it will take more than one frame with your finger held on the key. Or you might tap it and it might register twice. So really, I think the joystick should be very similar. See, joystick.h has got get joystick buttons, which returns a 16-bit unsigned integer, which is just everything. And then I've got joystick 2 up and 1 and everything, which is doing the same sort of thing that I was doing myself. I think I can just put this into my macro that I've got here. I think I might need to have a buttons current frame and a buttons previous frame. I'm going to go and do some coding and then I'll come back. So I've yet to run this code, but hopefully this should probably work, I think. Because what I've got is a previous and a current joystick, just the same as the keyboard. I've got an update function that works just like the keyboard. So it reads the buttons in and then copies them to the previous frame every frame. I've got an initialization function. And then in my main, I've added printing that out to the debug overlay. And then I just initialize the joystick. Or do I initialize the joystick? Have I remembered to do that? No, I haven't. So let's do that here. Right, so let's send that across to the Agon and see what happens. Now, I've not added any extra debug printing on the screen, so we'll just leave it like that. We won't run the serial copying thing. Let's just see what happens if I run the code. Well, I'm mildly confused that I can't see the text that should be printed in the debug. So where's that gone? Right, I think I've maybe done something useful. Let's send the data. More debugging is needed. So I made a bit more of my debugging screen. It now prints out bits at the bottom. And when I press the stick, you can see a different bit lights up. I don't know why those 2 bits are always 1, but it's the GPIO pins, so maybe they do something else and they're just there. So I can do up, down, left, right, fire. So this is now working. So you saw that I had the bits and the bits light up. Well, it turns out that I'd got joystick 1 and joystick 2 swapped around. I don't know where that happened. I'm going to trust that this is correct, but then the silk screen on the board says joystick 1 and joystick 2. And I'm not tracing the pins to work out exactly which GPIO pins they go to. So I just swap them around in my code. Look, we've got in main, joystick 2 is now the ones that we're looking at. And in the player, if you press joystick 2 left, you're moving left. If you press joystick 2 right, you're moving right. It's pretty cool. I got severely confused with which bit was being set, to the point that I went and had a chat with ChatGPT, and it even told me that I was wrong. Like, they're sort of, I don't know, improving this a little bit more. So I asked it some questions about bits and binary to load it up so it knew what I was talking about. I didn't talk to it too much so it didn't lose track of what's going on. Didn't run out of the free tokens either. So I was talking about setting bits and resetting them and clearing them. Then I asked it this thing of like, my joystick code says this, but it doesn't work. What's wrong? And it kind of says nothing's wrong. You're just misunderstanding what's actually being set, and I'm going to write that in bold. You human are the thing that is wrong. And it goes through and explains it, and it is actually correct. And yeah, turns out that I was misunderstanding it, because working out which bit in a byte maps to a bit mask and which one you're talking about kind of fries your head. You just have to play with it until it stops frying your head and eventually just works because you've hit it hard enough. But all of that aside, if I now turn off my debugging and I start the game, it doesn't work at all. That's amazing. I was all set there for showing you it working. Let me just check I've compiled the right code. One moment. Okay, I believe I've found the problem. The problem is once again me. Can we spot the problem? The problem is in this line of code and this line of code here. Let's follow it through together. Is joy pressed? Is key held? Was key held? Was joy held? Is joy held? Key. Key should not be key. This is why I don't do live coding. You would just watch hours of me faffing around, shouting at your screens as I make very, very silly elementary mistakes. Let's recompile this again. But I do like that I have a nice little routine. You can see I've been sending that quite a lot. So clean it, build it. Ooh. If statement has empty body. Put the semicolon on a separate line to silence this warning. I've upset the compiler. So is joy pressed? Warning, if statement has empty body. What is it complaining about? I think I've missed a bracket off somewhere. Now that matches that. That matches that. That matches that. Oh! That has one missing just there. That has one missing just there. Okay, that's happy. That was a nasty sneaky bug. Oh my god, it works. Finally. That's only taken all evening. Oh my god. And it works properly. You can't hold it and it skids across the screen. That's nice. I also really like my debug screen. It's one of my favourite bits of the program. The fact I can turn it on and off just like that. There's something a bit weird though with, it's either this ancient joystick, maybe it's got dirty contacts, maybe it's just the state of the GPIO pins, maybe they float around if there's nothing plugged in, but watch. If I unplug the joystick, you can see it goes a bit mad. Like it thinks everything is pressed, and if I touch my fingers on the GPIO pins, sometimes they flicker. So that's interesting. I hope that's not dangerous to the board. So yeah, I don't know what that is. That's quite exciting. Hardware's fun. Doesn't behave like software. Software just works or crashes. Hardware can do weird things when you don't expect it to, and then next time it doesn't do them at all. I need to get into more hardware. This is interesting. It sets off a certain part of my brain that wants to understand why it's doing that. Right, there we go. I need to find another joystick maybe, see if it works with that. But there, that's cool. Right, happy days, that works. So there we go. That was kind of fun, wasn't it? Bit of soldering, bit of low-level programming, poking around with GPIO pins, and my cool Atari joystick that is so old that, like, it's a bit rattly and falling to bits, but I kind of like the thing. You know, I'd like to maybe improve that joystick controller, or make a different one that works with better joysticks, or gamepads. The Nintendo ones don't work the same, and it could be quite fun trying to program one of those maybe. Or a Super Nintendo one, so it has a few more buttons. I feel a bit limited by just having a single action button and 4 directions. But also a pretty good fun project, you know. I got to program some low-level code with this. You got a bonus extra random video because I thought, hey, I may as well make a video whilst doing a bit of soldering. So yeah, hope you enjoyed it, and I'll see you in the next one.